Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, determine the points at which prime of f at x is equal to 0 for these functions. So let's start with the first function. So f at x equals 2x minus square times x squared minus 9. So we have to find the derivative of this function and then set it equal to 0 and solve for x. Now this function is made up of two functions that are being multiplied. So the first function is 2x minus 1 squared, and then another one is x squared minus 9. So since this function is a product of two functions, we'll have to use product rule to find the derivative of this function. So our first step is prime of f at x equals. So for product rule, we'll start with the derivative of the first function, so 2x minus 1 squared. So we'll have to use chain rule because this function has an inner function 2x minus 1, and then the outer function is the exponential function with the exponent 2. So we start with the derivative of the outer function, and for that we'll use the power rule. So we'll move the 2 to the front and we'll subtract 1 from the exponent times the derivative of the inner function, and the inner function is 2x minus 1. So the derivative of 2x is just 2 and the derivative of 1 is 0 because 1 is a constant. Then times the second function and then plus the first function, so 2x minus 1 squared times the derivative of the second function, and the second function is x squared minus 9, sorry. So the derivative of x squared is 2x as per the power rule. So we move the exponent 2 to the front and we subtract 1 from 2 and then minus 0 because 9 is a constant. So now we can simplify this expression. So prime of f at x. So in the first part, so 2 minus 0 in parentheses is just 2. So we multiply the 2 at the front and this 2. So we get 4 times 2x minus 1 exponent 1, but we don't show 1 as an exponent, times x squared minus 9. And then plus, so 2x minus 1 squared, and in the parentheses we have just 2x. So we don't write 1 as the exponent. Now we can set the derivative equal to 0. So we'll sub in 0 on the left side. And now we can simplify this equation by doing common factoring. So we can factor out a 2 and we can factor out 2x minus 1. So now we are left with the first part, we are left with 2 from the 4 and then just x squared minus 9. And then from the second part, we are left with just 2x minus 1 times x. Now we can simplify the expression in the square bracket. So we can distribute the terms in the parentheses. So we can distribute the 2 and we can distribute the x. So in the next step we get 0 equals. So we should keep the 2 and the 2x minus 1 as it is because we have to solve this equation. So we should not distribute those terms. So we get 2x squared minus 18 and then plus 2x squared can combine like terms in the second parentheses. So we get 0 equals 2 times 2x minus 1 times, now here 2x square and 2x square are like terms, so we get 4x squared and then minus x minus 18. Now we have to factor this trinomial. This is a complex trinomial, so we can use the crisscross method or the decomposition method to factor it. So I can show you the crisscross method. So here we can write the factors for 4. So the factors of 4 will be 4 and 1. And for negative 18, so we can do negative 9 and 2. So the idea is to get a sum of negative 1. So if we multiply, so 4 times 2 is positive 8. 1 times negative 9 is negative 9. And then negative 9 plus 8 is negative 1. So now we can write the factored form. So the factored form so for factored form, we'll use the numbers like this. So it'll be 4, so 2x minus 1 will stay as it is. And then we'll write 4x minus 9 and then x plus 2. So this is the factored form for this equation. Now we have to find the x values. So we should set all these factors equal to 0 and then solve for x. So our first case is, so 2x minus 1 equals 0, and then the second case will be 4x minus 9 equals 0, and then x plus 2 equals 0. So from the first case, so we can move the 1 over to the right side by adding 1 to both sides. So the ones on the left side will cancel each other out. So we get 2x equals 1, and then we can divide both sides by 2. So the 2's on the left side will cancel out. So we get x equals 1 over 2. So that's our first x value. Now for the second one, so we'll add 9 to both sides. So the 9's on the left side cancel each other out. So we get 4x equals 9. And now we can divide both sides by 4. So the 4's on the left side will cancel each other out. So we get x equals 9 over 4. So this is our second x value. And for the third one, we'll subtract 2 from both sides. So the 2's on the left side will get cancelled out. So we get x equals negative 2. So for this function, we've got 3 x values at which the derivative is equal to 0. So now we have to find the corresponding y values. So we'll sub in these x values one by one in the given function. So let's start with x equals half. So we do f at 1 over 2 equals, so we do 2 times 1 over 2 minus 1, and then square times 1 over 2 square minus 9. Now we can simplify this as f at 1 over 2 equals, so 2 times half is 1, so we get 1 minus 1, and then half square is 1 over 4. That is a square object. Now 1 minus 1 is 0, and that will make this whole expression equal to 0. So f at half is equal to 0. So the first point is half comma 0. Now we can sub in x as 9 over 4 in the given function. So f at 9 over 4 equals, so we do 2 times 9 over 4 minus 1 and then square, and then times 9 over 4 square minus 9. Now 2 times 9 over 4 will be equal to 9 over 2. So now we can use our calculator. So 9 divided by 2, which is 4.5, and then minus 1, which is 3.5, and 3.5 square is 12.25. And then times, then in the second part, so we'll do 9 over 4 square, which is 81 over 16. So we'll do 81 over 16 and then minus 9. And that is equal to negative 3.9375. And now we can multiply these terms. So 12.25 times negative 3.9375, which is equal to negative 48 point, so negative 48.234375. Now we can also write this in fraction form. So if you want to write it in fraction form, so we get negative 3087 over 64. So the second point will be, so 9 over 4, comma, negative 3087 over 64. So this is our second point, and now we can find our third point. So for third point, we'll sub in x as negative 2 in the function. So f at negative 2 equals, so negative 2 minus 1 square times negative 2 square minus 9. So we get f at negative 2 equals, so 2 times negative 2 is negative 4, minus 1 is negative 5, and negative 5 square is positive 25, times, now negative 2 square is positive 4, and minus 9 will be negative 5, which is equal to negative 125. So the third point is, so negative 2, negative 125. So these are the points at which the derivative is equal to 0 for the first function. So now we can analyze the second function. So I'll use a different color. So again, we'll start with the derivative of the function. Now this function is a rational function, so we can use the quotient rule to find its derivative. So prime of f at x equals, so as per the quotient rule, so we start with the derivative of the numerator, and the derivative of 5x will be just 5 times the denominator, x squared plus 1, then minus the numerator, which is 5x, times the derivative of the denominator, and as per the power rule, it will be 2x plus 0 over the square of the denominator. Now we can set this derivative equal to 0, 0 equals, so now we can simplify the expression in the numerator, so we can distribute the 5 in the parentheses, and we can also distribute the negative 5x. So we get 5x squared plus 5, and then negative 5x times 2x, will just be negative 10x squared because the 0 will go away over x squared plus 1 and then square. Now we can simplify the numerator by combining like terms 5x squared and negative 10x squared. So we get 0 equals, so 5x squared minus 10x squared is equal to negative 5x squared plus 5 over x squared plus 1 and then square. Now we can solve this equation by cross multiplying the denominator, and that will make the denominator go away because 0 times any term is equal to 0. So we get 0 equals negative 5x squared plus 5. Now we can move the x term to the left side by adding 5x squared to both sides. So 5x squares on the right side will cancel each other out and we get 5x squared equals 5. And now we can isolate x by dividing both sides by 5. So 5's on the left side will cancel each other out and same on the right side. So we get x squared equals 1 and now we can apply square root to both sides. So on the left side the square and the square root cancel each other out and we get x equals plus minus 1. So we get two x values at which the derivative is equal to 0. So now we'll sub in these x values one by one in the given function to find the y value. So let's start with x equals positive 1. So we'll sub in x as 1 in the given function. F1 will be equal to 5 times 1 over 1 plus 1. So we get 1 equals 5 times 1 is 5 and in the denominator 1 square is 1 and 1 plus 1 is 2. So the first point is 1, comma 5 over 2. So now we can find the second point for x equals negative 1. So we'll sub in x as negative 1 in the function. So f at negative 1 will be equal to 5 times over negative 1 squared plus 1. So we get f at negative 1 equals, so in the numerator we get negative 5 and in the denominator, so negative 1 squared is positive 1 and 1 plus 1 is 2. So the second point is negative 1, negative 5 over 2. So this is the second point which the derivative is equal to 0 for this function. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it and subscribe to Homework Help. Thank you very much and have a nice day. Bye.